Okay, so we're back for part 2 here. And again, we've learned 2 ways that we can describe this mathematically. We can describe a translation. Let's take number 3, translate point M. Here's point M, using the rule. Okay, so translation of xy, the change is going to be x plus 4, and then y plus 1. So if you go plus 4 in the x direction, that's going to the right. So this really means we're going to go right 4. And then in the y direction, if you go positive, that means you're going up 1. So from point M, we're going to count right 4, up 1. Here's M prime. The translation vector, if we had written it, would have been 4, 1. Okay, so depending on the textbook or the worksheet or the website, you may see translations written like this, or you may see them written in this way with the vector. And this is kind of nice with the vector. It's a little bit easier. Let's say I pick a different point. I'm going to put another point here. Let's say we did 2, 1. 2, 1. I'm going to call that A. That's the preimage. So 4, 1, if I take 2, 1, what this is telling me is to take my x value and add 4. And take my y value, which is 1, and add 1. Add 4, add 1. And what we get is 6, 2. So if A is 2, 1, A prime, the image is 6, 2. Let's see if this works. So the translation vector tells me to go right 4 and up 1. Here's A prime, and that is 6, 2. Okay, it works. That's kind of cool right there. And so the vector looks like this. If I draw the arrow, that would be the translation vector drawn out. You don't have to draw that, but again, we're just counting left, right, and up, down when we make the slide. Okay, so the last 2 problems here for number 4 and number 5. For number 4, it says state the image of each point after a translation t. So we're going to take our xy's, our ordered pairs, and we're going to change them x minus 3 and y plus 2. Now, one thing you can do, we're going to take each of these. These are the pre-images. This is where we're starting from, and they're saying find the image. Well, we can look at this visually. If you wanted to graph these, and then you could count, this would be minus 3 for x means we go left. Up, or positive 2 for y means we go up. So you could do that. What I think is easier is we can take this negative 7, 2 and substitute for x and y. Here's our x value, y value. So the translation says take your x value and subtract 3. So we do negative 7 minus 3. Take your y value and add 2. Negative 7 minus 3 is negative 10. 2 plus 2 is 4. Here's the image. We're done. Let's say it's 3, negative 4. xy. Take the x value, subtract 3. Take the y value, add 2. And so we get 0, negative 2. You're just plugging in the values for x and y and working them out. X minus 3 and y plus 2. Negative 1 minus 3 is negative 4. 0 plus 2 is 2. So you can do this algebraically. You can just do the computation. Or if you wanted to, you could plot these points and then count left 3, up 2. But it's going to be easier, I think, algebraically. So let's do the last one here, number 5. State the preimage of each point if the translation rule is t, x, y, x plus 1, y minus 4. So this means we're going right 1 and down 4. The y direction minus is down. If I wanted to write the translation vector, it would be positive 1, negative 4. Now here's the thing. This time they give us the image, and we need to find the preimage. We need to find the starting point. So this is different because I'm not going to put 6 and 0 for x and y. These are not the start. These are the outcomes. This is what I get out of this. So if I do x plus 1, I have to end up with the image x value, which is 6. If I do y minus 4, I have to end up with 0. So can you think of numbers to put in for x and y to make these work? Well, x would be 5. 5 plus 1 is 6. And you can get this, by the way. You can just solve the equation. Subtract 1, you get x equals 5. Okay, y minus 4 is 0. To solve that, we'll go plus plus, and we get y equals 4. There's your answer. There's your preimage. So we're ending with 6, 0. So 5 plus 1 is 6. 4 minus 4 is 0. Okay, negative 8 and 10. That's our image. That's where we end. So x plus 1 would have to give us negative 8. Y minus 4 would have to give us positive 10. Subtract 1. So we get x is negative 9. Add 4. And we get y equals 14. That's our starting point. And again, you can check. If I take negative 9, add 1, I get negative 8. If I take 14, subtract 4, I end up with 10. And then the last one is 3 comma negative 5. Okay, so I'm going to end with 3 for my x. So x plus 1 equals 3. Y minus 4 equals negative 5. And so we'll go minus 1. We get x equals 2. And here we'll go plus 4. Negative 5 plus 4 is negative 1. Okay, now if you don't want to do it algebraically, we could try to graph it. I think this is going to be a little more time consuming. But if I plot 3 comma negative 5, for example. Now this is where we finish. So we need to find the point where we went right 1 and down 4. You could try to work backwards. So instead of going right, we're going to go right and down. So let's go left 1 and up 4. And look where it puts you. 2, negative 1. Okay, I just think that's more work to do that. I'd prefer to solve it algebraically. And that is the end of part 1 of the notes. That's the end of the translations.